Hi everyone. Today we're going to learn about reference angles. First of all, let's talk about the definition of reference angle. The reference angle measures the closest distance of the terminal side to the x-axis. This is actually the terminal side. So the closest distance from the terminal side to the x-axis is reference angle. Notice that reference angles should be formed with the x-axis and should always be positive, and it's always an acute angle. So I'm going to do some examples for you here so you can understand exactly what do we mean by reference angle. Let's start with angle 50. So the first thing that I do is to draw this angle. Angle 50, the initial side is going to be here, and the terminal side is somewhere like this. So this is my theta. Now, to find the reference angle, I'm going to find the closest distance of the terminal side, which is this one, to the x-axis. The closest distance of this side to the x-axis is the same as the angle that we have, so it's this one. So I'm going to call the theta, the reference angle as theta prime. So theta prime is equal to 50 degrees, the same as my original angle. The distance between this line and the x-axis could be either this distance or this distance, but I'm going to take the smallest one, the closest one to the x-axis. So this will be my angle, the reference angle actually. Now let's see what happens if I have 130 degrees. So the angle 130 is going to be here, like this is the starting, the initial side, and the terminal side is going to be somewhere around here. So this is 130, and this is my terminal side. The closest distance of terminal side to the x-axis is going to be here. This is the closest distance. So this time I'm not going to take this side, I'm going to take the other side of the angle. So this is the theta prime, and it's going to be equal to 180, because this is 180 minus 130, and that's equal to 50. So the reference angle is 50 degrees. Again, notice that we are taking the smallest one, and the angle which is made with the x-axis, not with the y-axis. So we're not going to take this side. We are going to take this side as the reference angle. And it's always an acute angle. So although my original angle is 130, is an obtuse angle, but I'm going to take the acute part of this line. Now let's do the next one, negative 120. Okay, negative 120, the initial side is here, and the terminal side, because this is negative number, I'm moving this way, like clockwise. For positives, we move counterclockwise, and for negative angles, we move clockwise. Okay, so as I move this way, negative 120 is going to be somewhere like this. So this is negative 120. Now and this is my terminal side. Now the closest distance between terminal side and the x-axis is going to be this space that you see here. This is the reference angle. I'm not going to take this one, but this one. The distance between this point and this point, because this is negative 180 and this is negative 120, is 60. And notice that I'm taking just 60, not negative. Although my angle is negative, and even if, like, maybe we say because I'm moving this way, so this is also going to be negative 60, but we don't care about this negative here. We are just going to drop that and just take it as a positive value, because reference angle is always positive. Now the last one, 705. Okay, we know that 705 is 360 plus 3 45. So in order to draw this angle, I'm going to start from here and then make a full circle here and then continue 90, 180, 270, and 345 is going to be somewhere like here maybe. So this is my angle, and this is the direction of the angle. This is 705. Now, the reference angle is the distance between the terminal side, which is here, and the x-axis, so it's this line, this space actually. And what is the measure of this space? Because we made a 365, and then this from here to here is 345, the rest of that here is going to be 360 minus 345, which is 15. So theta prime here is equal to 15 degrees. Okay, now let's see what happens to our reference angle if the theta is a quadrantal angle, means lies on a quadrant boundary. So let's see what happens here. This is my coordinate plane. Now, if my angle is on the quadrant border, means it's going to be either here, 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 or here, like on the quadrant border, maybe here. Okay, so if the angle is, the theta is here, that means the initial side and the terminal side, both of them are here, like on this line, both of them on each other, because the angle is 0. This is when the angle is 0. So the distance between terminal side and the x-axis is 0, because terminal side is actually on the x-axis. So if theta is equal to 0, then theta prime is also equal to 0. What if my angle is 180 degrees? So the terminal side is going to be here. This will be the initial side and this will be the terminal side. Again, the distance between terminal side and the x-axis again is 0. So if the theta is 180 degrees, theta prime is also going to be 0. So I don't have to write that here. So for 0 and 180, theta prime is 0. What if my angle is 360? That means this is my initial side, and then I make a whole circle and then go back where I came from, and this is going to be 360. 360 is again on the x-axis. So the distance between the terminal side and the x-axis is again 0. So for 0, 180, and 360, theta prime is 0. What if my angle is here? Then the initial side is here and the terminal side is here. Now, what if the distance between the terminal side and the x-axis? It's equal to 90. So if theta is equal to 90, then theta prime is also equal to 90. If my angle is here, 270, so the initial will be here and the terminal is here. So this will be my angle. And the distance between this line, the terminal side, and the x-axis again is 90. So for 270, again, theta prime is 90. Now let's see how we can find the reference angle when the angle is measured in radian. First of all, we need to draw the angle. So I'm going to start drawing this angle, 7 pi over 4. We know that we always start from 0 here, and this is pi. I need to make the denominator of this, or like all the corners, the same as pi over 4. Like the denominator should be 4. What should I do? I'm going to write, let's say, pi. The denominator of pi is 1. To make the denominator at 4, I'm going to multiply both top and the bottom by 4. So this will be 4 pi over 4. So I change this pi at 4 pi over 4. If I make a whole circle, this is 2 pi. I need to change this as a denominator of 4 as well. So this will be equal to 8 pi over 4. Why? Because 2 pi has a denominator of 1, so times 4 times 4, this will be 8 pi, and the denominator is again 4. Okay, now this point. We know that this point is half the way from 0 to 4 pi over 4. So half of 4 pi over 4 will be 2 pi over 4. You just divide 4 pi by 2 and you get that. This point, you just need to add 1/2 of this distance, because all these are half of this distance. Like all these quarters are equal to each other and they're all equal to 2 pi over 4. So another half is actually added here. So 4 pi over 4 plus 2 pi over 4 will be 6 pi over 4. Now I have all the corners. Now it's easy to find 7 pi over 4. The initial side is here, and the terminal side, 7 pi over 4, is going to be here, because 7 is between 6 and 8. So it's going to be here. This is my angle. And I started from here and ended here. Here's the direction. So this is 7 pi over 4. Now, what is the reference angle? The distance between terminal side, which is this one, this is the terminal side, and the x-axis, so it's here. This is my theta prime, which is 8 pi over 4 minus 7 pi over 4. So you subtract these two to get the difference between them, the distance between them. That is pi over 4. This is the reference angle. Okay, now let's do 4 pi over 3. I'm going to erase all these so I have some space here. Okay, 4 pi over 3, again we start from 0 and pi. Make this have the same denominator, so this will be 3 pi over 3. And all the way to the starting point is 2 pi, which if I change it to the denominator, to have the denominator of 3, it's going to be 6 pi over 3. 6 pi over 3. As you see, 6 divided by 3 is 2. So it's going to be the same as what we had before, 2 pi. Now, this point is half of 3 pi over 3. Half of 3 is 1.5. So 1.5 pi over 3. And then here, 1/2 is going to be added here. So this will be 4.5 pi over 3. 3 plus 1.5. Okay. Now, where is 4 pi over 3? 4 is between 3 and 4. Okay, so because 4 is between 3 and 4, the angle is going to be, the terminal side of this angle is going to be somewhere like this. The initial side was here, and this is the terminal side. And this is the direction that we moved. So this is 4 pi over 3. Now, what is my reference angle? The distance between terminal side and the x-axis. This is the reference angle. Theta prime is going to be 4 pi. Oh, I'm sorry. Let me fix that. 4 pi over 3 minus 3 pi over 3, which is equal to pi over 3. This is my reference angle. Okay, now let's work on this one, negative 25 pi over 9. Again, I'm going to erase these to make space and move it here. Okay. We start from 0 and pi is here. The denominator is 9, so we make this 9 pi over 9. But here's the actually point. We have a negative angle. That means here we are moving to the negative direction, this way. So I'm actually moving from here to here. So half the way from 0 to 9 is going to be here, not this one. Basically, this is negative 9 pi over 9. And half of 9 is 4.5. So 4.5 over 9 is here, negative. Then I continue moving this way. this 4.5 and 9 pi over 9 will be added. This will be 13.5 pi over 9 negative. And then if I go back to here, this point where 2 pi actually was located here, 2 pi is going to be negative 18 pi over 9 because 18 over 9 is 2. The angle that I have is 25 pi over 9. So I have not reached there yet. So I have to continue going around actually. So another half should be added to negative 18 pi over 9. So this will be negative 22.5 pi over 9. 4.5 plus 18. So these two angles are located on the same point. Then we continue moving here. Another 4.5 will be added, and this will be negative 27 pi over 9. Now we have actually exceeded 25, so I can stop making these circles. 25 is between 27 and 22, so the angle is going to be here. Starts from here, and my terminal side is going to be maybe here, somewhere around this. What is my angle? I started from here, made a whole circle, and then stopped at this point. So this is my angle. Make sure if your angle is something bigger than 360 or 2 pi, you draw enough circles or enough curves here. Anyway, so this is negative 20 pi 5 over 9. Now my reference angle is going to be this distance between the terminal side and the x-axis. What is the distance between them? 27 pi minus 25 pi. Oh, this was 25. I guess I made a mistake here. So this was 25 pi. Okay, so this distance, which is 27 minus 25, is my reference angle. Theta is going to be 2 pi over 9. Notice that I didn't take the negative. I just ignored the negatives. I just subtracted 27 minus 25, and then that is 2 pi over 9. So this is my reference angle, because we said that reference angle is always a positive value. Okay, so this is the first part of this lesson. I'm going to stop here, and I will make another video for the second part of this lesson. Have a good day.